But first we got to get the basics down. So I'm on my notes, chapter 3, section 3.1. At some point I'm probably going to take a grade for these, so if you haven't yet printed them, you need to get them printed, and if you can't do that, remember, I'll leave a copy for you down at the front desk. But the time for that's running out. We're starting, we need to have the notes. So, here we go. The question is, label as a power function, an exponential function, or neither. This chapter is about exponentials, so I'll start with that. Exponential functions are like this one. This is exponential. The definition of an exponential function is basically y equals a times b to the x. In other words, you have a number times another number to the xth power. If your equation fits that format where these are numbers, constants, then you have an exponential function. So this is an exponential. Remember, the exponential is one of your BFFs. If you used what we talked about, use what's in the book, you memorized e to the x, but that's the same as 1 times e to the x. That's your exponential. And you'll remember that exponentials have an asymptote on the x-axis, contain the point 0, 1, and look like that. Unless we mess around with them and flip them and stuff, which we'll talk about in a few minutes. But that's an exponential. This is what an exponential equation looks like. So this one is clearly exponential. Are any of the rest of them exponential? No, not a single one of them. Because none of the rest of them fit this pattern. Now, some of you might be wondering about this one. Remember, it has to be a number to a power, not x to the x. That's some kind of weird equation. You can mess around with that on your calculator if you want. But it is not exponential, and it is not a power function. Either's this. What's that? That just says y equals 16. So that's a constant function. That's a horizontal line. That's nothing. This is a power function. A power function is x to a power, as opposed to an exponential function, which is a number to the x. Do you see the difference between those two? X to a power is called a power function. And we've just spent a whole chapter talking about power functions. This is an even power, so we know when we graph it, I don't know exactly what it looks like, but I know it starts up and ends up, because that's what even power functions do. That's totally different than an exponential. All right, now the next part asks you to do a little work with some exponents, basically, without your calculator. So let's see how much of this you remember. Because it's important that you remember how to deal with the exponents. All right, so I'm going to let x be 0, so I'm going to plug a 0 in there. What is the value of this function if I put a 0 in there for the x? Anybody want to? Yes, it's 3. Because anything to the 0 power is 1. That's what you got to remember. Anything to the 0 power is 1. So the value of that function is just 3. Perfect. All right, what about this one? 6 times 3 to the negative second. What happens when we raise something to a negative power?
Put it over 1.
Exactly. Very good. So impressed. So that's going to be 6 times 1 over 3 squared, which is 6 times 1 over 9. which is 6/9 or 2/3 as our final answer? Not bad, all right. What about the next one? -2 times 3 to the 1/3. What does that mean? 3 to the 1/3.
Like exponent? So like, can I get exponentially squared?
Well, fractional exponents mean radicals. So if you forgot that, please make a note of it. It's kind of a big idea. Fractional exponents are radicals. So this is really -2 times the cube root of 3. 3 to the 1/3, that's a fractional exponent, means it's a root. Since it is a 1/3, it is a cube root. If it had been a 1/4, it would be a 4th root, and so on. Fractional exponents always mean radicals. Fractional exponents mean radicals. We're getting ready to head to logarithm land here in this chapter. And in logarithm land, there are no radicals, so you're going to have to be able to change back and forth between fractional exponents and radicals. So without a calculator, we're done. That's it. -2 cube roots of 3. That's our answer. And then the last one. Now we got a couple of different things going on here with this exponent. 8 times 4 to the -3/2. Now, let's start with the negative. You told me here, or somewhere here, that the negative flipped the thing or put it in the denominator. So what that means for this problem is, instead of having 4 to the -3/2, we're going to have 1/4 to the 3/2. Does that make sense to everybody? Because the exponent is negative, just like it was here, this became 1/3, so this becomes 1/4 to the 3/2. Now that's a fraction, that exponent. Fractional exponents mean radicals. So this, forget the numerator for a second, this is what tells you which radical you have. Just like this meant I had a cube root, this means I have a square root. But it's not just the square root of 4, it's the square root of 4 cubed, because there's a power on that too. That says 4 cubed, this says the square root of that. So I have 8 times, well, what's what's the square root of 4? 2, and cubed is 8. So this fraction actually becomes 1/8. The square root of 4 is 2, and 2 cubed is 8. Now, some of you may prefer to think about it as the square root of 4 cubed. I did the square root of 4 and then cubed that. You may want to do the square root of 4 cubed. That's fine. What's 4 cubed? 64. What's the square root of 64? 8. So the answer is the same either way. I always like to take my root first. Keeps my numbers smaller, but it doesn't really matter. There's 2 things happening here. The square root of 4, cubing. So anyhow, the answer to the problem appears to be just 1. Does anybody have a question about that? Quick review of some exponents. All right, now you're going to write your own exponential. Now, remember what I told you before, an exponential fits the pattern y equals a times b to the x. That is the style of equation that you are writing. Don't be confused by the way the information is presented. Would you agree that what I have is two ordered pairs, 0, 3 halves, and negative 2, 108? We talked about this back in chapter 2 when we were doing lines. If you write something like f of 4 equals 6, this is f of x. So the x coordinate is the one in the parentheses. So I have 0, 3 halves and negative 2, 108. Start, you can only handle 1 point at a time. This isn't like lines. Please don't do slope and stuff like that. No. This isn't linear. Take your point that has a 0, whichever point has a 0. And I am going to try real hard to always give you a 0. It's a little more complicated otherwise. Take the point that has the 0 and plug that point into your equation. Keeping in mind that that point is x, y, you're going to have 3 halves equals a times b to the 0. Now I think you'll see why I suggest you start with that point. What does this tell me? If I put 3 halves in for y and 0 in for x, what does this say?
3 halves equals x.
Exactly. Because b to the 0th is just 1. So now I know, remember in your original equation you have to find an a and you have to find a b. Well, you already know a. Now you know that a is 3 halves. So now we just have to figure out our b. Any idea how we're going to figure out the b?
Plug in negative 2
Yeah, exactly. Plug in the other point. So 108 equals 3 halves b to the negative 2nd. Remember, kids, your point is x, y. Please don't plug anything in for b. The 108 is going in for y, and the negative 2 is going in for x. So now I have this. I'm going to solve this for b. I'm eventually going to figure out what b equals. How would you suggest I start that?
Take b to the negative half and make it into a fraction. So you have to like take b to negative 2 and put that in the denominator.
Okay.
Or would you just divide 3 halves?
Well, I would do that first. Actually, both of the things you talked about have to be done, but I would just get rid of that number first. Remember, you said divide by 3 halves. That's perfect. I don't have a calculator, so instead of dividing by 3 halves, I might want to multiply by 2/3. Will that accomplish the same thing?
Yeah.
Yeah. So, let's see, that's 216 divided by 372. So 72, is that right? Yeah, equals b to the negative 2nd. Now I'm going to do what you said also to do, and that is rethink this. B to the negative 2nd is 1 over b squared. Let's not freak out. That's a super simple equation to solve. What can I do? How about cross multiply? So 72b squared equals 1. Just cross multiply. And b squared equals 1 over 72. How will I find b then? What am I going to have to do? I need just plain b for my equation.
square root.
Yep,
Square root.
just square root it. Yep, that's exactly right. So when I square root that, I'm going to get 1 over, oh goodness, the square root is 72. 6 root 2. Not really supposed to have radicals in the bottom. So do you remember how to deal with that? How do we not have a radical in the bottom?
You have to multiply by radical 2.
Exactly.
On the top.
Yep. So this is going to give me the square root of 2 over 12, because root 2 times root 2 is 2. So 6 times 2, so 12. And that is my B. As ugly as it is, that's my B. So writing my answer, my A was 3/2. So I have 3/2 times root 2 over 12 to the x. And that is my exponential function. Now there was a lot of arithmetic in that, so I've got a real easy one here. Let's do this easy one and make sure you understand the concept. This is going to be a lot easier. So we've got 2 points. We're going to write an equation, y equals a times b to the x. And the little hint I gave you is always start with the 0, the y-intercept point. Always start with this guy. So 3 equals a times b to the 0th. What did a turn out to be?
3.
3, yeah. So we have y equals 3b to the x. Now I'll plug in my other point. So 6 equals 3 times b squared. How will I solve that?
Divide by 3.
So, yep, so 2 equals b squared, and how do I solve that?
Square root.
Square root. So my final answer will be 3 times the square root of 2 to the x power. Now, a couple of comments. It hasn't really been an issue in our 2 examples, but when you have an exponential, you might be tempted to combine your A and your B. For example, if you had something simple like this, you might be tempted to combine these. Don't. This one has an X, this one doesn't. Don't ever combine those together. They have to be treated as 2 separate numbers. All right. Oh, the other thing I want to mention is a lot of times when we take the square root, we do plus or minus. Would you agree with me? That's really standard procedure, but not in exponentials, because one thing that I didn't tell you is A can be anything, but B must be bigger than 0. B is a positive number. So whatever you are raising to the x, it must be positive, always. So when I do the square root in exponential problems, I always just take the positive root. All right. Now, number 4, we have a little more review stuff to do. This is all stuff we talked about before. So I don't know if you, we just talked about it a minute ago, but your exponential looks like this. So this is the point 0, 1. And this is your asymptote, at least on this end, it's an asymptote. This is a picture of y equals 2 to the x. It's also a picture of y equals 3 to the x and y equals e to the x. That is your basic, generic, run-of-the-mill exponential. Now, who can tell me what happens when you take your x value and subtract 3? What does that do to our picture? Who remembers? You know this. Chapter 1.
Moves up, down 3. Moves the x down 3.
It moves it for sure, but we're not going down. Remember, we would go down if we had 2 to the x minus 3. That would take me down. But when I'm doing something directly to the x, that moves me left and right, right? Correct? And which way does it go when it's x minus 3?
To the right.
To the right. So that means every single point is going to move right 3. So what is that point going to be now? It was 0, 1 before. What's it going to be now? It came straight right 3 units.
3 minus 1, I mean 3, 1.
That's 3, 1, yep. The asymptote hasn't changed because we haven't moved it up or down at all. Now we've just moved it to the right 3 units. Now what about the next one? Now there's a negative put on the problem or into the problem. Do you remember what negatives do? Negatives flip you. Which way do I flip if the negative is on the x?
Isn't it just upside down?
Actually, no. Upside down would be something like negative 2 to the x. That would turn you upside down. When you put the negative out in front, by the way, recognize that's still just 2 to the x. It's the negative is in the front of it. That tips you upside down. When you put a negative on your x, it is a sideways reflection. It's a reflection across the y-axis. So we're going to take this picture and reflect it across the y-axis. Now this shows a very important concept. With exponentials, the basic exponential, which is the black, is a growth model. The farther you go, the higher you go. You've heard the expression exponential growth, especially with the virus going around. That's exponential growth. When you reverse that and put a negative on that exponent, now it becomes exponential decay. So the black curve is growth, the red curve is decay. And the difference is the black curve, this was the equation, and the red curve, this was the equation. Now, tell me about negative exponents. What does that do to this 2? When I put a negative exponent on there, what happens here?
Makes it 1/2.
It does. In your equation, your basic equation, y equals a times b to the x, I told you that b has to be positive. And that's true. If b is bigger than 1, you're going to have a growth model. If b is less than 1, bigger than 0, but less than 1, you're going to have a decay model. You will see that 2 different ways. You'll look at your actual b value, or you'll note that the exponent is negative. either one of those two things, having this be less than 1 or putting a negative on there, is going to turn your growth into decay. Oh, crap-ola, guys. Our time is up already. Okay, all right. Well, thank you very much. I will, see you tomorrow, I hope. So have a great day. Come back during flex if you want. Otherwise,
Thank you.
I'll see you. Bye-bye.
Thank you.
You're
Thank you,
welcome.
everyone.
Bye-bye.
Thank you.